We are going to start chapter 11 today. Chapter 11 is all about rational expressions and functions. Today we're going to talk about simplifying rational expressions. So to start things off, to tell you what a rational expression is, a rational expression is simply a polynomial divided by another polynomial. Okay? Now, whenever we are talking about rational expressions, one of the big important things we need to talk about today is what's called an excluded value. An excluded value is a value that's not going to work. So kind of like whenever we talked about domain, about what x can possibly be, kind of like that. So let's say I look at this fraction, a minus 1 over a. If we're talking about what a can and cannot be, you could pretty much plug anything in for a, but what you're going to get hung up on is that denominator right there. Denominator cannot be 0. So my excluded value for this one, a cannot equal 0. If we were, maybe let's flip it around. If I do a over a minus 1, what we're looking for whenever we're talking about these excluded values, I'm looking for when is that denominator going to be 0? What would a have to be if the denominator was 0? Hopefully we can figure that out. If a was 1, the denominator would be 0. So we have to start off by doing that. A cannot be equal to 1. Okay, so the big idea today is simplifying rational expression. So to simplify rational expression, we're going to do 4 simple steps. The first thing we're going to have to do is we are going to have to factor everything. I told you this wasn't going away. Keep factoring. Factor everything. The second thing we're going to do is we're going to do what we just talked about. We're going to state the excluded values. So figuring out what my variable cannot be. The next thing we're going to do is we're going to simplify by dividing out any common factors. Divide out any common factors. And then lastly, sometimes you won't have to do this, but a lot of times you will. We want to simplify. I apologize, my pen's not very good. Okay, so first thing, factor everything. Second thing, state any excluded values. Third thing, divide out any common factors. And lastly, we are going to simplify. So let's try some of these. Oh, sorry. Very, very important thing. Very tempting, what I see all the time, is you see an x squared and x squared and you're like, oh, I can cancel those out. You cannot do that. I'm going to talk to you more about that tomorrow when I return, but do not do that. That's the biggest mistake you can possibly make with this section. Don't do that. Every time you do that, a kitten dies. Okay, so we're going to simplify each expression and then be sure always state any excluded values. So number 1, let's do 4x plus 12 over 6. First thing we do is we want to factor everything. So if you look at that numerator, I can factor out a greatest common factor. 4x and 12 both have a 4 in common. So I can factor out a 4. When I factor out a 4, I'm left with x plus 3. The denominator can't do anything. We're going to leave it the same. Now, if I look at what I have, we're supposed to state any excluded values. So my denominator can't ever equal 0. Well, if my denominator is 6, 6 is never going to be 0. So I don't have any excluded values. So what we're looking for next is we're going to divide out any common factors. So the only thing that has any common factors is the 4 and the 6. And hopefully we know they have a 2 in common. So you can divide out a 2 from both of those. So we're going to have 2 times the quantity x plus 3 over 3. That would be your answer. Okay, number 2. Let's say we have 2n minus 3 over 6n minus 9. Okay, first thing, we want to factor everything. So the numerator up there, I really can't do anything with 2n minus 3. There's no greatest common factor, there's no exponent, so I can't do anything there. In the denominator, 6n and 9, they have a 3 in common. So we're going to factor out a 3. And I'm left with 2n minus 3. Okay? Next step is we're supposed to state any excluded values. So if I look at my denominator, I need to decide when is that factor going to equal 0? What would n have to be? And this is one where it may not jump out at you right away, so if you're not sure, here's what you're going to do. I know 2n minus 3 can't be 0. Well, if 2n minus 3 can't be equal 0, if I solve for n, that will tell me what n would have to be when that denominator is going to be 0. So if I add 3, I have 2n equals 3 divided by 2, so we'd have n equals 3/2. So what this tells me is that whenever n is 3/2, my denominator is 0. So my excluded value, that's part of my answer. N cannot equal 3/2. So then the other thing I need to do once I state my excluded values, now we're looking for common factors. Now you see how they both have a 2n minus 3? I can divide that out as long as it matches exactly. So I should be left with 1/3. So your answer is both the 1/3 and then the n cannot equal 3/2. Okay, number 3. Say we have 2p minus 24 over 4p minus 48. Okay, we want to factor first. So in that numerator, they both have a 2 in common. So when I factor out a 2, I'm left with p minus 12. In my denominator, those both have a 4 in common. So I'm left with p minus 12. Okay, next thing, before you simplify, you want to state any excluded values. So if you look at that factor there, that p minus 12, if p minus 12 equals 0, so if we were to solve this, this would tell me that p would have to equal 12. So that's my excluded value. If my denominator is 0, that means p would have to equal 12. Can't have my denominator equal 0, so p cannot equal 12. That's my excluded value. Now if we go back to look to simplify, they have a p minus 12 in common. They also have a 2 in common, so if you divide out a 2 from both of those, you get 1/2. So your answers are 1/2, but p cannot equal 12. Okay, number 4. 3x squared plus 6x over 3x cubed. Okay, first thing, let's factor the numerator. So my numerator, they both have a 3x in common. I'm left with x plus 2. In my denominator, I can't factor that, so it's just going to be 3x cubed. Now next, if we look for excluded values, if 3x cubed equals 0, to solve that, you divide by 3, and then you've got x divided by 3, so you'd have x cubed equals 0. Well, think about this. What would you have to cube to give you 0? It would have to be 0. So I know that x cannot equal 0. Think about it. If you took 3 times 0 cubed, your denominator would be 0. Cannot have 0 as a denominator. So once you state your excluded values, go back and see what you can divide out. So divide out common factors. So I see that they have a 3 in common. They also have an x in common. So one of those x's in the denominator is going to cancel out. So my answer should be x plus 2 over x squared. Now it's really, really tempting to try to divide out those x's there, but you can't. That's what I was saying on that last slide. This last slide. That was the killing the kitten thing. You cannot do that. You can only divide out factors. Okay, and once again, I'll kind of hit more on that tomorrow when I return. Okay, number 5. 2b minus 8 over b squared minus 16. Okay, if I look at my numerator, those have a 2 in common. I'm left with b minus 4. In my denominator, we've got to get really good at factoring these. So the sooner you can start recognizing how to factor 2 terms, the better off we're going to be. To factor 2 terms, this was the difference of squares. This is where we had a plus and a minus sign. Okay, and so if you think about the foiling this, this times this has to give me b squared, so it'd have to be b times b, and then the middle term's going to cancel out. The last term needs to, that times that needs to give me a negative 16, so 4 times 4 gives me 16. b plus 4 times b minus 4. Okay, then don't forget your excluded values. Now in this case, I have 2 factors here. Okay, so if either one of those equals 0, it's not going to work. So I have to say, okay, well, if b plus 4 equals 0, that means b would be negative 4. So b can't be negative 4, because in my denominator it would be 0. Or if I say, well, b minus 4 equals 0, b would be 4. Well, if b is 4, my denominator is 0, so b can't be 4 either. I have 2 excluded values here. B cannot be negative 4, b cannot be a positive 4, because when b is 4 and negative 4, my denominator is 0. Okay, and then if we go back and divide out any common factors, they have that b minus 4 in common. So I'm left with 2 over b plus 4. And then my 2 excluded values are boxed over there. Okay, last one of these, and then we're going to talk about a different concept. Let's say we have m squared plus 7m plus 12 over m squared plus 6m plus 8. Okay, to factor both of these, both of them we're going to have to look for factors of c that add to b. So in my numerator, I'm going to look for factors of 12 that add to 7, which would be 3 and 4. So we've got x plus 3 times x plus 4. In my denominator, I'm looking for factors of 8 that add to 6. It would be 2 and 4. So we've got x plus 2, x plus 4. Okay, state your excluded values. So once again, I've got two things. If either one of those equals 0, it's not going to work. So if x plus 2 equals 0, x would have to be negative 2. So x cannot be negative 2. If x plus 4 is 0, that means x would be negative 4. So I know from that x could not be negative 2 or negative 4. Then if I go back, cancel out any common factors, those x plus 4's cancel out, so my answer should be x plus 3 over x plus 2 with my excluded values. Okay, this is my favorite part of this section. We are going to learn what I call math magic. Okay, so here's what this looks like. Let's say I have something that looks like this, x minus 1 over 1 minus x. If I'm looking to simplify this, these are really, really close. X minus 1 and 1 minus x, it's subtractions, it's the same variables, but these are not the same thing. Now, it doesn't mean I can't simplify this, but I'm going to have to do, like I said, what I call a little math magic. So here's what we're going to do. We are going to take that numerator, and we are going to factor out a negative 1. Okay, so watch what happens. From the numerator, we're going to factor out a negative 1. Now, when you factor out a negative 1, it just changes the signs. So that positive x becomes a negative x. That minus 1 becomes a plus 1. Now, think about this. If I were to redistribute that negative 1, I would get that back, which is why I'm able to do that. Now, we're going to leave the denominator the same. We're going to leave it as a 1 minus x. But now look what happens. In the numerator, let's leave that negative 1 out there. But if I just flipped these around and wrote the 1 first, look what it turns into. It turns into a 1 minus x. So now if you look, they have a 1 minus x in common. All I'm left with is that negative 1. Math magic. Pretty cool. So let's try some. Okay, number 7. Okay, number 7, we've got 5 minus 4n over 4n minus 5. Okay, notice they are almost the same. They almost match exactly, but not quite. So pick one of your factors. Let's just stick with the numerator. Let's factor a negative 1 out of the numerator. When you factor out a negative 1, it just changes the signs. So this is going to be a negative 5. And this is going to be a plus 4n. My denominator, we're going to leave it the same. We want it to stay the same. So then, in my numerator, if I flip that around, I would have 4n minus 5. And my denominator still have 4n minus 5. Now, we still don't want to forget, we still need to state our excluded values. So I know if 4n minus 5 equals 0, not going to work. So if I were to solve this, we would get 5/4. So my excluded value, n cannot equal 5/4. And then if we go back to our problem, the 4n minus 5 will cancel out. We should just get negative 1. Okay, number 8. 4m minus 8 over 4 minus 2m. Now, if you're looking at this one, trying to do some math magic only works if they match exactly. They're just in the wrong order. See, I had 5 and a 4n, and then a 4n and a 5. These don't match exactly. So what we're going to start by doing is we're going to start by factoring, because that's how we always should start anyway. In the numerator, those have a 4 in common. I'm left with m minus 2. In the denominator, they have a 2 in common. I'm left with 2 minus m. Okay, notice they match exactly, except they're flipped around. So from this one, let's factor out a negative 1. So that 4 becomes a negative 4. Now to kind of skip this step here, when you factor out a negative 1, it allows you to flip those numbers around. So this is now a 2 minus m. In my denominator, I've got 2 over 2 minus m. Okay, let's look for our excluded values. If that 2 minus m is 0, m would have to equal 2. So my excluded value, m cannot equal 2. And then if I go to cancel out my common factors, they have a 2 minus m in common. They also have a 2 in common, so I should just have negative 2. Okay, let's try a few more of these ones. Number 9, so I have v minus 5 over 25 minus v squared. Okay, we'll leave the numerator the same. I can't do anything with that. But in my denominator, I've got a difference of squares. So I'm asking myself, what squared gives me 25? What squared gives me v squared? Well, 5 squared gives me 25. V squared gives me v squared. So we're going to take 5 plus v times 5 minus v. Okay, if we maybe go for our excluded values, if that was 0, v would be negative 5, so v cannot equal negative 5. If my second factor was 0, v would have to be 5, so v cannot equal 5 either. Now when we go to cancel out our common factors, these two factors look like they match almost the same, but not exactly, so we're going to do some math magic. So let's factor out a negative 1 from the numerator. So negative 1, when you factor out a negative 1, it allows me to flip those around. In my denominator, we'll leave the 5 plus v, we'll leave the 5 minus v. Now the 5 minus v's cancel out, so my answer is negative 1 over 5 plus v. Number 10, y squared minus 16 over 4 minus y. Okay, if I factor my numerator, that's a difference of squares. So I've got y plus 4 times y minus 4. In my denominator, I can't factor that, so I'll leave it as 4 minus y. For my excluded values, if my denominator is 0, y would be 4, because 4 minus 4 gives me 0, so I know y cannot equal 4. Okay, they match almost exactly, but not quite the same, so let's factor a negative 1 out from that one. Okay, let's put that negative 1 out front. We'll leave the y plus 4 how it is. When I factor out a negative 1 from y minus 4, it turns to 4 minus y. In my denominator, we'll leave that as the 4 minus y. So the 4 minus y's cancel out. You could leave your answer as negative 1 times y plus 4. If it's just a negative 1, we're probably going to go ahead and distribute that. So negative y minus 4 would be your answer. Okay, we're just going to do two more that are not more like the first ones. Maybe not have to do any math magic, just a little bit tougher factoring. So number 11, let's do 3x squared plus 19x minus 14 over x squared minus 49. Alright, so we're going to have to do some factoring, and if you look at that numerator, we're going to have to do the airplane method, and the airplane method takes a couple steps. So I'm probably going to go over here, and I'm going to do my factoring separate, and then I'll plug it in down here on my fraction. So when I start with 3x squared plus 19x minus 14, I know I'm going to be looking for 3 times 14 is negative 42, so I'm looking for factors of negative 42 that add to 19. That's going to be a 21 and a negative 2. Now remember, with the airplane method, since I've got that 3x there, it's going to be 3x and 3x, and then we fill in our factors, plus 21 minus 2. And then the last thing with the airplane method, you have to land your plane. Those have a 3 in common. The 3x minus 2 doesn't have anything in common. So to fill these in over here, when I divide out a 3 from the first factor, we've got x plus 7. The second factor stays the same, 3x minus 2. Okay, in my denominator, that x squared minus 49, that's a difference of squares. So I get x plus 7 times x minus 7. Okay, if we do our excluded values, we should have x cannot equal negative 7 for that first factor and a positive 7 for that second factor. And then go back, cancel out my common factors, those x plus 7s, I'm left with 3x minus 2 over x minus 7. It's just a little bit tougher factoring. Okay, last one, number 12. Let's do 2x squared minus 5x minus 3 over x squared minus 2x minus 3. In the numerator, since you have an ax squared, you're going to have to do the airplane method again. So 2 times negative 3, we're looking for factors of negative 6 that add to a negative 5, which should be a negative 6 and a positive 1. So when you set up your factors, since it's a 2x squared, you should have a 2x in the front of your factors. And then we're going to do minus 6 and a plus 1. The first factor has a 2 in common. The second factor has a 1 in common. So I should get x minus 3 times 2x plus 1. Now in my denominator, I don't have to do the airplane method because it's just x squared. So we're looking for factors of negative 3 that add to a negative 2, which should be a negative 3 and a positive 1. So we have x minus 3, x plus 1. Okay, for my excluded values, if x minus 3 equals 0, x would have to equal 3. If x plus 1 was 0, x would have to equal negative 1. So those are my two excluded values, 3 and negative 1. And then if we cancel out our common factors, we should have 2x plus 1 over x plus 1. Oh.